Good morning, good afternoon, good evening, wherever you are. So the topic for today's discussion is, as Ganesh said, the AI and the machine learning in database world. So I think you heard about all the data science, machine learning things going around, a lot of things happening, as Dr. Panda was pointing out. And here, my core focus is on how do we build the machine learning process in directly on a database, right? In database machine learning process. So I have some use case scenarios working with IBM DB2, and I will go over some of the idea is we'll go over some of the challenges what we go through in the day-to-day regular or traditional machine learning process, and what happens when we do the same thing in database directly in database machine learning. So that's a kind of a thought for today's discussion. Okay, so about Werner, we are one of the largest carrier in Midwest America. We have almost like 8,500 trucks and 35,000 trailers operated all over North America and Mexico. So we have, and again, we are kind of one of the largest carrier. And our company started with one truck. Our owner, he started with one truck way back in 1950. And now he grown up to, in 2022, we grown up to 8,500 trucks and 35,000 trailer the docking station. And we are kind of over $2 billion turnover company in Midwest America. So the agenda for today is, let's just review. I mean, a lot of things has been covered in the machine learning, but I just still want to go through some basics. And some of you are expecting this, I think, in the presentation, but just still want to cover some of the basics on the AI, machine learning, and deep learning, and some of the machine learning types, and how we are differentiating from a traditional process to that in database machine learning. And let's just review the supporting databases. And I don't know whether we'll have enough time to go through the demo, but we have a setup running on a Linux server in our University of Oregon. And we can show you what exactly we are doing there. And also the next iteration, one of the things as Dr. Panda was challenging, the data is growing, right? We are getting more and more data, and we need a bigger servers and bigger CPU, bigger processor, and bigger memory. And how do we take challenges of the bigger servers? So we are kind of setting up a big server on Oregon, but we haven't completely finished it. But we can show you that what exactly we are going to do and how we are going to challenge with that big data. All right. So if you look at AI versus machine learning with the deep learning, right? I mean, this is a simple picture. Basically, it shows AI. Everybody talks about AI, right? I mean, we're all talking about it. Wherever you go, it's AI is inbuilt, and it's basically what we're doing is imitating the intelligent human behavior, right? If you're able to make a machine to imitate the human behavior, that's it. That's a AI concept. But it's like a bigger umbrella, and within that we have a machine learning, which is kind of applied to application of AI that allows the system to automatically learn and improve, right? Based on your trained data set. You're making the system to learn and improve from the experience, continuous learning. And so far, I don't see anything like 100% prediction, right? It's all, you can go from anywhere from 95 to 99. As long as you go to 99% prediction, that will be the ideal solution. But we don't reach 100% because it's still a computer, right? I mean. And the deep learning is a process built within machine learning process where basically it uses, again, complex algorithm and a deep neural nets to train a model, right? Which is very deep. So the topic for today's discussion is just machine learning, period. We are not going to jump onto deep learning process, and we are just going to look at the machine learning and how this process has been traditionally built in, and how the database vendors, right, various database vendors, how they are challenging them this process in their world. Okay. So again, the simple definition of machine learning is the field of study. It's way back in Arthur Samuels said in 1959. field of study that gives computers the ability to learn without being explicitly programmed, right? I mean, so basically you're making the system to learn with a set of data sets, just feeding the data set and it will learn, and using that learned model, you just go and do what will happen in future, this kind of prediction. And again, this is just a vague classification, the objective. The idea of what is the idea is classify data based on models. So you have to get the right model and data and classify them. And based on the classification, what we are planning is we have to find the prediction, right? What will happen if something the data changes, how that's going to work in future. So that's kind of prediction, future prediction. So that's the primary goal for this machine learning process. Again, this is simple types. So various types, right? Machine learning, we are looking at supervised learning and unsupervised. And again, within supervised, we have two classifications. One is classification and regression, whereas in unsupervised, it's just clustering model. And you can, I mean, we don't need to jump onto each category, how it works. You can always get all the information. But the topic for today's discussion is only supervised learning. And we are looking at look at the classification model for a particular scenario. This is, I'm just showing a traditional machine learning steps, right? I mean, there are like so far we have like 6 steps involved in a traditional setup, wherein we collect data, is a start with collect data, and cleanse the data set, and explore and visualization, and third step, and fourth is build a model, and fifth is evaluate and deploy, right? I mean, these are like core machine learning steps involved in any if you go to any country, any setup, this is like an overall process for machine learning, all the steps involved. And if you look at this scenario, this picture, this is basically I'm showing a traditional setup, right? Wherein I mean, again, there are so many tools available in the world, and you can use any set of tools to set up the machine learning process. But again, this is I'm just showing a complex and a time-consuming model, and the traditional process is just you're feeding a set of data set from unstructured, structure, you name it, right? Sending from a external feed into a Kafka API, streaming the data set, and you pushing into a Spark streaming, where basically the process where exactly you're building a data model, and machine learning model, and then you store the data like model in a JSON database. That's like a MAP or a JSON database, and then you're feeding it based on the analysis. You just go and analyze the data set, right, from that JSON. And if you look at that picture, there are like a lot of steps involved, and how complex the setup is. So anytime when somebody is talking about machine learning, you think about right now, there are so many steps involved, so many tools you need to use. And again, you need to be expertise in going through this entire setup. So this is them showing a traditional setup. And coming to the discussion for today in database machine learning. Now, database vendors, what they're doing is, if you already have a database, right? I mean, so database setup in your environment. What they're saying is, you don't need to go through all these steps, right? I mean, there are like multiple steps. You have to data collect, process, store, because most of the time you're spending data for collecting from various systems, and you're feeding, and which is kind of very expensive. So what we are saying is, we are making the database like if you already in your company or your place, you already store data in RDBMS. The idea is, we don't need to transfer the data to anywhere. We will come to you. I mean, the database vendor saying is, well, I will come to your place, and you don't need any complex tools. I have a set of processes, and using that, you can do a machine learning within the database itself. So you don't need to transfer the data. And you build your model, and you do a predictive analysis within the same database. So you don't need to spend a lot of money outside. And as you add more processor and memory to that server, where you're running the database, you can increase the number, the volume of processing, and anything comes into that big data. Anything you bring it, you just push it to a database, and it will do the magic. So that's the idea of in database machine learning. So if you look at it, supporting database, right? There are a lot of database. I mean, most of the database support in database machine learning, and the topic, the discussion for today is IBM DB2 warehouse. That's what we are going to take as for this today's discussion. And apart from this, Kinetica, Microsoft SQL Server, even on-prem as well as Azure, it supports machine learning process in database machine learning. Oracle, they have same thing, and Amazon Redshift, and Vertica, Blazing SQL, Google Cloud. Again, most of the vendors, what are the database vendors, you name it, they are making the database more versatile to processing, to include the machine learning processes. And again, this is something new, and to get into that, you need to make sure that you have the right version of database, right? I mean, you cannot go to a SQL Server 2000 and run a machine learning process. You need to go to the latest version, and you need to check with the vendor for the applicable version. And I can show you today for DB2 how that's going to support, and which version is going to support. So these are kind of some challenges. I was showing you that comparing that in database and machine learning with traditional. So when you're looking at the traditional, it's the main the trouble is the talent gap, right? You need to have a talent, and the data need to be transferred with expensive cost, infrastructure, and integration of ML. There are so many steps involved. Whereas when you're running the machine learning within the database, in this case DB2, as long as you know the SQL language, but that's enough, right? I mean, everything is behind the screen. It processes and predicts. And everything is, you don't need to move the data to multiple places because the data is stored in it's one place. And everything will be run through SQL-based interface queries, right? So, which is pretty easy and pretty straightforward. And that's what we are going to look in that in the DB2 machine learning process. This is one of the survey we did. We looked at the data available right now. If you look at the entire industry, right, we see that 66% of the data, right, for the machine learning projects are readily available relational data set. So, when you look at RDBMS and unstructured data, 66% are still sitting in that the tables, in the RDBMS tables. So that's kind of one survey we get. So let's now jump onto that. We'll dive into that machine learning. And as I said, for today's discussion is we are going to look at DB2, IBM DB2, and see how data set machine learning can be performed in in database machine learning. Any questions so far, guys? I mean, if you have any questions, you can stop me. So far, I just covered the fundamental, the concepts of machine learning process and steps involved in that setup. All right. So what IBM did is IBM DB2 version 11.5.4 onwards, they called the databases machine learning, right? I mean, to get into the machine learning process, you need to upgrade your database to 11.5.4. Then only you can use the feature. So if you're, for example, if you're running on 11.5.1 or 11.1, the old versions, you cannot do that. You need to upgrade your database to the 11.5.4 onwards. That's where that machine learning is introduced in IBM. So what we are showing is these are the various all these steps, right? I mean, available inbuilt within the database. So, for example, we want to right from exploring the data set and pre-process and train the data set and evaluate and the inference, right? So all this to go through all these steps, you don't need to go through a costly equipment or costly Kafka, where I was showing that, right? I mean, different tool set. You don't need anything. All you need is your data set available in a database, IBM DB2, and that's it. That's all enough, right? I mean, you can go and start processing for the machine learning process. So how do you do that? Let's go through this step process, right? So this is one setup we did in University of Oregon. We took one of the Linux server. So one thing I want to mention is, see, we have IBM AIX, we have AIX and Linux partitions. So unfortunately, the AIX power servers are not directly supporting this machine learning process, right? I mean, they are still working on it, but the core what we have in power server, they're not directly supporting the machine learning. So we have to go to a Linux environment, right? So as I was explaining earlier, we'll see how we are going to do that in AIX server. But here, what I'm showing is it's a vanilla, plain vanilla Linux server we pulled from Oregon system. We made a partition on Linux available. And we made, these are some of the configuration settings. We will make that environment as a machine learning process, yes. And then we set up a database. And this is the challenge, right? When you call since install objects with IDAX, so basically it builds a set of IDAX store procedures, and which we'll be using it for building the machine learning process. So this is just, I'm showing a setup, what we used for machine learning. So the idea is in this scenario, what we are doing is, see, as I said, we are a trucking company, right? So we have to do the predictive analysis for basically for maintenance, showing advanced maintenance and what tire and the tire wear pattern and then battery. I will show some of the examples in future, but these are the same something. I mean, in case the vehicle needs a maintenance, we want to look at the based on our trucks are fit with so many sensors. There are thousands of sensors set up. So we get the data feed from those sensors through a Qualcomm unit. And the idea is for this exercise, what we did is we replicate those information, like capture those information from trucks, feeding it to a DB2 11.5.6, SSR 11.5.4 onwards it supports. So in this case, we did 11.5.6. feed the data into the staging tables and build a machine learning model. And any new data coming in, we want to go on based on the past experience that get the outcome for, is it going to, does the truck needs any maintenance, or does that truck tire need to be, you know, the tread wear or the wear pattern, based on the wear pattern, we need to make the advance notice to the driver, go and change your tire, right? I mean, those are kind of some predictions we want to do with this data set. So again, as I said, the collect data, right? The step number one is collecting data in the machine learning. So we collect the data through a replication process, feeding to a DB2 database. So the step two, this what I'm showing is when I mentioned earlier, when you run that sys install object, right, on the IDAX. So what it does is it creates a set of store procedures, and the step two in the any machine learning process, data exploration, we use these are the store procedures we use. So when you call the store procedure with the set of table name and the data set, it will basically do the analysis for you. So these are just for the data. I'm just showing that quick indicator. What are the store procedures used for each steps? And this is the data transformation where we split data for training and test data. So we use the these store procedures for doing the data transformation. And model building, again, there are various. These are all like primary models coming with IBM. So IBM said, if you use this store procedure like IDAX growth duck tree, you can do a decision tree. And if you want to linear regression, you can do a linear regression based on the data set what you have. And a naive base, that's like yes or no flags. If you have them, then you can use the naive base algorithm. And clustering, k-means clustering, you can use the k-means algorithm. So these are the readily what I'm showing is readily available store procedures built in, and you can use them for making that, you know, building the machine learning setup. And model evaluation. And if you again, we are focusing on building a confusion matrix. So there is a confusion matrix store procedures. So we build that model. Evaluate the model. And for the model inference and deployment, we use this predictive store procedures, right? So in this case, our main interest is naive base. So we are not doing any, our exercise is for a predictive naive base model. So we use the predictive naive base and then predict the model. Okay, so now come to the fun part. So this is what I'm showing is one simple truck data, right? The kind of data what we get from our tractors. So if you look at all this data in a column data set, the feature I'm showing is the input data. Like I'm showing temperature, vehicle speed, sensor, vibration, low engine load, coolant temperature, you name it, right? Engine speed. I mean, we are getting so many the data, incoming data coming in. And based on this data, what our idea is, we want to predict set the maintenance flag. Does that vehicle need a maintenance or not, right? Yes or no? So if you look at the data set, this is a sample data set. We collected a set of, a large number of data set. And this is a set and we predicted, so if you look at it, I'm not showing all the columns, but I'm showing a set of columns and pulling from the table. So in this case, if you look at the incoming load, engine RPM, speed, GPS, bearing, and based on the data set, and we train the data, right? We train it, and we find what should be the maintenance flag. I mean, does a truck need a maintenance or not, right? Yes or no. In this case, 0 or 1. So we fix that based on that incoming data. And that's where we do a labeling. First, we'll do a labeling based on a set of data set. Once the label is done, what we'll do is we will send the data, right? So what I'm showing here is the data set sitting in a table called fleet nav base. So this is the table, fleet nav base table, input table. And the first thing is I'm doing is doing a summary. I'm just doing a data exploration. And second thing is data transformation. So in this scenario, I'm taking the fleet-based names and I'm splitting data into two data sets. One is for training, another is for test. And I can give you the fraction, that is how much data you want to do a train and how much you want, based on, in this case, 95%, right? 0.95 is the 95% of the data set, input data set go for training and 5% go for testing. So once the data is transferred, all I'm calling is a nav-based IDAX nav-base model. So I'm passing the IDAX nav-base in table is, you look at it, there's a train table, right? And the target column I'm specifying is a maintenance flag. So you look at the maintenance flag, and based on whatever the classified, the model is, the data is classified, you build that model. So when I run this process, just it builds a model, and then model size came to be 15292. And I print the model. I can show the model what it is. And then here, this is what I was talking about, the predictive nav-based step number 5. When I call that predictive nav-base with the model name, and then again, I'm looking at the test data. So in this case, what I'm doing is, once that model is built with the trained data set, I'm passing that test data where I don't have a maintenance flag. Basically, I want to know what how that model is behaving. So I'll pass this 5% of the test data into the model and show me what is outcome, right? So I went to process this, and then here is the model evaluation. The last one is model evaluation, which is confusion matrix. Basically, you are building a confusion matrix based on what you have from the test data, which already predicted values, right? And when I pass the test data into the model and how much it's predicting based on without passing that machine flag, the maintenance flag. So here I'm building a confusion matrix to show how much data is accurately predicted, right? So in this case, when I pass through this, I had as I said, 375 rows in the test table. So when I compared, there were like only 61 records were different, right? It didn't 61 records, even though what I'm saying is the maintenance required or not required, it predicted differently. So in this case, the percentage different is 16%. So I will say that my model is like a 84% accuracy in this case, right? So again, this is to start with the start process, but again, we will gather more data set, different kind of data set, then run through the process and see how much closely is predicting that. We have to bring the percentage different to as small as possible, so that your model is more accurate to future outcome. So this is the exercise what we did in Venus system and a Linux partition, and this is what we found our prediction. So what is the future is, again, as I said, we are trekking. So this is the one scenario is how long when the truck is on the road. Based on that predictive analysis, we can say how long a truck can run without any maintenance. And based on the data set, what we getting for drivers, right? So we want to, because we hire drivers every day, and there are a lot of turnovers. We have like 11,000 drivers working for our company. We want to make sure that we are retaining everybody. And if somebody is quitting in next 30 days, we want to know. So for that, we'll use that same pattern based on the driver demography or driver data set. We can predict whether a driver can quit in next 30 days or not. And company turnover in future, 5 years, 10 years, based on my financial data, I can see what is going to be turnover in the next 5 years or 10 years. And again, with this, once I start predicting the maintenance pattern, I can, because we are spending a lot of money, like millions of dollars for accidents. I mean, if one truck involved in an accident, we are spending like millions, right? So by predicting the right maintenance process, I can prevent accidents, and also I can push the load to a customer at the right time. If I know I am going through a maintenance, if I know I'm going through the maintenance process, I can delay the load and accurately tell the customer how long it's going to take to reach. So that's the kind of customer satisfaction. And battery life, that's the life of the battery. We can predict based on that, past data set. Again, this setup we did in a Linux environment, and our future focus is we are getting IBM. Ganesh is helping us to build a Power 10 server in Oregon. But the problem is in the Power 10, the AIX, we cannot run a machine learning process. So what we're doing is we are building an OpenShift environment. So OpenShift is nothing but a partition on AIX, and we run Linux on OpenShift. And even though a partition running on Linux, but still when you backend, it's going to grab the power of Power 10, right? Because Power 10, as Dr. Ponda was pointing out, future is going to be a lot of data set, and there are so much, we need so much power. So we are going to utilize the Power 10 processor, but we are going to run this on an OpenShift environment. And for that, we are still, testing is in progress. And in a month or two, we'll be seeing how that's behaving with that, running that in a large environment. I think that's all I have. And if you guys have any Q&A, we can discuss now. And I think, Ganesh, I'm done. You can open for questions.